Since radioactive decay obeys first-order kinetics, we will use the first-order integrated rate law and the first-order half-life to solve the following problem. We have fluorine-18, a radioactive isotope that decays with a half-life of 109.7 minutes. We can use the half-life to determine the rate constant of the decomposition of fluorine-18. So part A, let's use the half-life equation given, knowing that the half-life is 109.7 minutes. We can rearrange and solve for K. We get K equal 6.32 times 10 to the minus 3. The units are going to be inverse minutes. Part B asks us to calculate the percentage that remains after 5.59 hours. So first, I'm going to convert my 5.59 hours into minutes because my rate constant has units of inverse minutes. So multiplying by 60 minutes over 1 hour gives 335.4 minutes. And I can use that as my T in the integrated first order rate law. We aren't given an initial concentration, but we can assume 1 molar so that our math is a little bit easier down the road. And the first order integrated rate law is the concentration of A naught over A equal to KT. Let's plug into this equation. Natural log of our A naught, which is 1, and we want to calculate the final concentration, is equal to K, which was calculated in part A, 6.32 times 10 to the minus 3 inverse minutes, times the time, which is 335.4 minutes. Simplifying, the right side gives us the natural log of 1 over A equal to 2.12. We have to use E to get rid of our natural log, and so we end up with 1 over A equals 8.33, and solving for A gives us 0.120 molar. So after 5.59 hours, there's 0.120 molar remaining. In order to calculate what percentage that is, we take our 0.120 molar and divide by the initial concentration, which we assumed was 1 molar, and multiply by 100. We end up with 12% remaining after 5.59 hours. Part C asks us to determine how long it takes for 99.9% to decay, which means that we would have 0.01% remaining. We assumed that our initial concentration was 1 molar, and if we know that 99.99% decays and only 0.01% remains, we would have our final concentration as 0.01 molar. Let's use those concentration values in our integrated rate law. So we have the natural log of 1 over 0.01 equals K, found in part A, 6.32 times 10 to the minus 3 inverse minutes. And this time we're solving for time. Solving this equation for T gives us 729 minutes. So after 729 minutes, only 0.01% of the radioactivity would remain.